Okay, we should be all set. Here is the link. And we can get going. Okay, so what is the topic today? We are the last, as I said, last lecture is going to be on dialogue. And I announced as the last lecture, but not the last class, because as you know, next Monday there is going to be the second midterm. I'm sorry, the exercises in preparation for the second midterm, which is going to take place on Wednesday. So when I wrote the last lecture, I meant really the lecture, but we will meet again in class Monday and Wednesday. Okay. So dialogue, it's maybe it's the reason why I became interested in natural language understanding, because I think that after all, dialogue, natural language is a great communication channel between human and robots, and dialogue is a key element in the picture. We have seen until now how to process sentences in isolation, so to speak, without considering much of the context, neither in large text corpora, but also not in an interactive scenario, which, as I mentioned, is probably the one which is of more interest, at least in my case. The one thing that made me closer to this natural language world. Okay, in particular, we are going to talk about the spoken dialogue systems. Okay, so in dialogue, there are other forms of communication that have a special framework for natural language, like social networks with the tweets and other short messages. Dialogue is based on a vocal interaction. So an essential component of a dialogue system is the speech understanding part. So the automatic speech understanding. And the spoken interaction are what makes us it's the most typical interaction between humans, and it is becoming also a key interaction for humans and devices. So we can issue vocal commands to our mobile phone, to several devices like Alexa that are in our room, and eventually we are going to talk and issue commands and have a dialogue with robots. So dialogue is really challenging, and there are a number of reasons why it is challenging. First of all, the communication takes place in a sequence of turns. And for the system, things that are very natural for us, like understanding when it's our turn to talk, or when it's the partner turn to talk, it's obvious. Not so much for an automatic system that needs to understand in the first place when, not only what to say, but also when starting an action is in a dialogue. Okay, so that's a first issue. And during the dialogue, we are getting back to the notion of speech act that we have already addressed earlier on. speaking about the communication between systems and showing how from a theory of human speech acts, eventually languages for communication among computing systems or computing agents were developed. In this case, now we are going to analyzing, to consider much closer the speech acts that are typical of, let's say, human conversation and human dialogue. So we need to distinguish, even for a simple interaction, whether the user is greeting, whether the user is asking for information, whether the user is requesting an action to be executed, and so on and so forth. And that's understanding the speech act of the user is a challenge. And some speech acts are particularly challenging. For example, a correction. Whenever there is a dialogue through the interaction, it is often the case, not only because the automatic speech recognition fails, but also maybe because of incomplete information, for many other reasons, that there is the need to confirm or disconfirm that a certain communication or that a certain message has been understood and correctly interpreted. And that's, as we will see later on in the class, it's one of the challenges. It's more difficult to understand a correction than to understand a command. Grounding. Well, grounding, it's specific for robotics, and of course we have already mentioned this concept and mentioned that the grounding in the interaction between human and robot takes place essentially through robot perception. But grounding means also, in a more general sense, to make sure that there is a common understanding after a certain exchange of messages or speech acts between the user and the robot, or between a user and the system. Because the discussion and the reference in the book is not specific to robots, but it's generally talking about different types of systems. And also dialogue as different types of structure. Sometimes we start with a topic and then we have a detour on another topic and then we go back to the previous topic. So each speech act may depend on several speech acts that have been that took place in the past, and moreover, there is not the structure is not a linear sequence, but there are branches and returns to a main subject or to a subject that was addressed earlier. So understanding the type of structure and understanding when a sub-dialogue, technically speaking, this is how this is called, this situation is called, starts, it's another challenge. And finally, dialogue can be robot-driven, can be system-driven, can be user-driven, or can be mixed initiative. And that's also a challenge because, again, a passive system that is simply answering questions on user requests, it's much simpler than a dialogic system, which may eventually start asking questions and then establish a conversation where the information flow is bidirectional, and that creates several interesting challenges. So studying dialogue is provides a very rich set of problems, and the challenges for successful. Still, it is the case that we do have a number of systems that now are implemented based on a dialogue. And it's no longer the case that these systems are limited to, this unpleasant phone answering systems that require information step by step and leading the user to exhausting the patients very quickly. I don't know how familiar you are with the systems that ask you to, say, make a reservation or read the numbers on the water counter in your home and things like this. Many of them are really, really cumbersome. But still, they are in place since a long time. So it's a technology that is evolving, and there is a lot of opportunities to make progress. Additional difficulties, not enough with what we said earlier, but some of them were anticipated, in particular, the fact that the dialogue typically creates a context of discourse, and therefore the dependencies or the output that the system can generate may depend on a sequence of steps that are far in the sequence. And an additional difficulty is that the language in the dialogue is much more informal, and sometimes a lot of information is taken for granted, or it's left implicit. And this, for example, may require the system to do inferences. One example of this would be that if the examples are, most of them that you will find in the book are with a flight reservation system. So what time do you want to go? Do you want to leave tomorrow? And the answer might be, I need to be in Milan before the start of the conference such and such. That's which is at 10 o'clock, say. And that's a plausible answer, but it's not the direct answer that the system would expect. So the inference there is that the system needs to understand that the flight time the starting time should be chosen so that it will match the requirement of the user in terms of arrival time. Another example is that in a dialogue, there may be significant disfluences, namely specific pronunciation or intonation, or even, especially I already made to you the example of a correction, and you said, I said Milan, did you understand? And that's one, the pronunciation in this case is maybe intended to be more understandable for a human, but that's not necessarily the case for a system. And finally, there is another specific challenge, which is the text-to-speech, which is required in order to transform a concept or information or the content of the message into a form that can make it more or less pleasant, more or less understandable by the user. So it is a challenging domain. And as with many other things, we only scratch the surface here. Speaking in terms of what kind of dialogic systems have been built so far and are in place and can actually be built, we have two types. a general classification in two categories. One of them is the category of chatbots that are typically there for entertaining, or they typically have no specific goal. And the idea is to create a system that provides coherent responses to the user. And the prototypical system of this category is ELIZA. We have already seen, and we are going to see it in more detail today. And the other category of dialogue system is the category of task-oriented dialogue agents, which can be personal assistants, and generally they help the user achieving a specific task. I earlier made the example of flight reservation, but that can be anything. Like the other example that I made is reading the values of the counters that of the water consumption, for example, or anything else along those lines. Typically, the systems that are already implemented as phone answering systems in order to reduce the personnel interacting with people. Unfortunately, at this time, this is at the expense of the patience of the user, so to speak, because these systems are not really fully satisfactory, at least the old fashioned ones. There is also, in this area, there is a substantial improvement due to the new results obtained through deep learning and through the introduction of the machine learning technology at large that can handle large amounts of data. Chatbots. We have three categories, subcategories into the chatbots, depending on the technology that is used in order to implement them. The first one is let's say the first one developed, which is rule-based. Then there is a second category, which is corpus-based. And finally, there is a more recent category, which is based on encoder-decoder technology, which essentially aims at guessing the next element in a sequence. And there are studies on the evaluation of these spoken dialogue systems, chatbots in particular. But in fact, the main evaluation tool at this point is still the user study, namely doing a quantitative evaluation through the analysis of the interaction with users. However, there are some studies on quantitative methods, but they are still not common practice. There is no accepted standard. So, starting from ELIZA, we are back to 1966. And the idea, as I mentioned earlier, from the designers was to implement a psychologist of a specific school of thought. And the idea was that the psychologist should help the user describing his own problems by not answering directly the questions or the assertions of the user, but rather bouncing them on the user itself so that the user can continue this process of providing more and more information about his or her form of whatever depression or difficulty that it might eventually have. And a subsequent system called Perry, it's worth mentioning for two reasons. One reason is that it was the first system that for which one can say that the system passed the Turing test. And this is in fact the case because it's along the lines of ELIZA, so namely a system for interacting with users along the conversation with the typical psychologist. And in fact, the Turing test was considered passed because psychologists could not distinguish the dialogues between the system and the human and between the psychologist and the human. Okay, so in the end, they were the dialogues were indistinguishable, sufficiently indistinguishable for the psychologists themselves. So let's see why. Oh, the other thing that I announced as one of the features of Perry is that for the first time it included a component for handling the emotional state, and therefore the system could answer from, let's say, with a good mood or with a bad mood, depending on the conversation. So I think this is some piece that I have already shown, but let's briefly review in order to gather a little more about the functioning of this type of system. And as in this ELIZA, conversation goes, men are all alike. In what way? They're always bugging us about something or other. Can you think of a specific example? Well, my boyfriend made me come here. Your boyfriend made you come here. He says, I'm depressed much of the time. I'm sorry to hear you are depressed. And if we continue on with the conversation, we will start understanding some of the patterns that the system uses. Let's go on a little bit and this will be clearer. Who else in your family takes care of you? My father. And the system answers, your father. You're like my father in some ways. What resemblance do you see? And you are not aggressive, but I think you don't want to notice me that. What makes you think that I'm not aggressive? You don't argue with me. Why do you think I don't argue with you? And here is one example. And it's when there is a not here, the system replies with what makes you think that I'm not aggressive? You don't argue with me. Why do you think I don't argue with you? So that's one of the patterns that we can identify, for example. And so on. Let's see how this is actually implemented. It's relatively simple because we have a language which builds on regular expressions. And here is an example of a pattern. We have let's say, a rule structure for this pattern response system, where on the left hand of this arrow, you have a description of a pattern. And on the right-hand side of the arrow, you have a response to that pattern. Now, the pattern, it's not a specific sentence, but it can include stars, namely placeholders for expressions that can be, in this particular case, anything. More generally, you can have expressions that can be specified through regular expressions. So in this particular case, we have a pattern where we have two such expressions, or two such placeholders. In the first, at the beginning of the sentence, and after, and between you and me. So what makes you think that you ate me is one example. So nothing before you, and then height between you and me. So this height comes in the third position in the pattern, and therefore the response, what makes you think that I tree you, means that in place of the tree here, the system will include the third element found in the pattern. Okay, so this will answer what makes you think that I hate you, because this tree refers to the third position in the pattern. And there are a number of several such patterns. And in order to characterize the full algorithm, there are two more things to know, and it's that the system is trying to understand what is the key, the most important word in the sentence, following the rule that the more as a word is specific, the more it is relevant for the conversation. And another thing is that there may be multiple matches in the set of rules, and therefore there is a match ranking, meaning that the rules are evaluated in a ranking, and the first one in the ranking is chosen to generate the response. And as a third thing, there is an escape for situations where the system does not know what to say. And typically, this, in this case, the system will make use of a sort of memory which keeps track in a smart way of previous steps of the conversation. So the system is backing up to something that was already in the system, in the conversation. And finally, the system like Perry would include also emotions. So that the response may change based on a specific emotional state, like fear or anger or anything else. This is for the rule-based chatbots. With the machine learning technology, and with the possibility of developing query answering systems, the approach to the design of chatbots, a new approach based on information retrieval was developed. Now, the system will store large corpora of dialogues where each element is formed by a stimulus and a response. Well, actually, maybe it's not correct to say a stimulus, but some human speech act and some response. The response could be a human response, or the response could be a system response. Generally, better, it's preferred to use human responses. So large corpora, for example, taken from phone conversations, they were used in order to train the system so that it will eventually be able to retrieve the one specific turn, namely pair with the speech act and the response, that is suitable to be used for answering the user, or for replying to the user, so to speak. So this means that an optimization based on the similarity between the query, it's called the query, but it may be any dialogue speech act of the user, and the turns that are stored in the corpora, the similarity is computed, and the turn with the highest similarity is chosen in order to provide the response which, remember that the turn is given by a query and a response. So the response is chosen for answering the user. Various other approaches have been tried in this case. For example, instead of storing turns, the approaches that store a text and then try to match the query with fragments of text and finding the fragment of text that matches best can provide a good response in a dialogue context, even though this may be less intuitive on the surface from the straightforward approach of storing a large corpus of turn-taking pairs. So that's the corpus-based approach, and the encoder-decoder is using transduction models, and essentially it's a machine learning version of an interaction in the style of ELIZA. And of course, there is, in this case, the system should try to avoid generic responses, but it will not be able to use any context. And this means that it's more difficult to keep coherence across multiple turns. This is also the case for a system like ELIZA, and you can, I don't know if you have had a chance to try. There are many chatbots in the net, and some of them you can easily see that they lose coherence between subsequent turns, and that's an indication that the conversation is with a chatbot rather than a human. It's the way to discover that. Anyone that wants to report an experience in interacting with a chatbot of some kind? I'm just curious because on the internet, I know that you can find chatbots that are claim that they pass the Turing test, which is not such a novel claim, but any experience in interacting with chatbots before we move on to another subject? Any comment on this? I don't see any movement on the chat. So maybe we can move on to the next topic, which is also the topic around which this little project is will be focused, will be centered. Okay, no comments on the chats, the chat bots. Okay, the second category that I anticipated is the category of task-oriented spoken dialogue systems. And they essentially are specific to a domain, and they are centered on a specific one or more frame. So we find here the notion of frame, and you understand why the frames were defined, they were put forward as one of the knowledge representation formalisms. Also, for example, in the lecture of description logics, we've been talking about on frames, but they are really applied in many fields, in particular in natural language, because around the frame, it is possible to model a situation where a specific context where the exchange of information can take place by a process called slot filling, which means that in order to complete the information about the subject, a certain number of pieces should be given or should be transferred. And such pieces are called the slots of the frame. So that's the structure of task-oriented systems. And here is one example of interaction that I took from the book, and it's based on this Goose system that was developed towards the end of the 70s. So it's an old system. So let's look at how the system interacts with the user. This is a flight reservation system. The system introduces itself. Hello, my name is Gus. I can help you plan a simple trip. Where do you want to go? I want to go to San Diego on May 28. What time do you want to leave? I must be in San Diego before 10 a.m. Would you like PSA flight 102 that arrives at 9:15? What's the next flight? Air California that leaves at 8:30 and arrives at 10. I'll take the first one. In what name? And this is the name of the main researcher developing this system, Dan Bobrow. And then the system confirms, this is very important, it's a confirmation that everything went well. And I have confirmed the following flight, PSA flight 102 on Wednesday from San Jose to San Diego that leaves at 7:30 and arrives blah, blah. And then it continues with the returning date. And you see, this is a typical example of slot filling. So the system in this case is based on a single domain, which is air travel reservation. And there is a specific frame structure that describes all the information that is needed in order to make a trip. And this trip is contains, it can be a one-way trip or two-way trips. If it's a two-way, in each of the two parts of the trip, the system needs to acquire information about the departure date, the location of departure, the time of departure, and then it will eventually identify a specific flight. And all this information is asked to the user one piece at a time through a process that, as I mentioned earlier, is called slot filling. Okay, so this is the general structure of this system. More precisely, the general systems of this category, they need to address the following steps. First, identifying the domain. In the example, the domain is a unique domain, but a system can be, for example, be able to handle at the same time flight reservation and hotel reservation, and understanding the domain is the first step. And then there is an intent determination. And in the case of the two domains that I mentioned earlier, there may be, for example, the reservation of placing a reservation, but there may be also deleting a reservation or changing a reservation. So those are different intents within the same domain. And once the specific frame for the achieving the task is identified, then the slot filling process starts, and until the system is willing to provide a response, which is based on translating the internal form of the response into text. So there is a text generation process, and in this first systems, this text generation was based on templates of the style that I showed you earlier in a simple form in the ELIZA system for providing a response based on, in that case, on the input, and in this case, based on the frame structure and content. The first systems were developed in this category are also based on a specific grammar which is attached to the structure of the frame. What does it mean? That the slots, they can be filled according to a grammar specification of the possible ways they can be filled in. And this means that these systems are typically able to detect location, and you can actually restrict in some of these systems the set of locations that are reached by through a certain airport, for example, and in this way also provide some input to the automatic speech recognition system that can work a little bit better when the domain of the possible answers are within a certain specified set. So the structure of the frame chosen is also a driver in this case for the grammar. And this is also helpful in particular when the system needs to, can eventually consider full sentences, like in this example where you see the intent is a show, and it's associated with a specific frame, and this frame is filled in with the flight specification, with an origin and the destination, the part date, and so on and so forth, which may actually be part of the same sentence. One of the things that makes the interaction with the dialogue system more cumbersome is the fact that the information is typically required one step at a time, while in a normal conversation, we would provide this information by combining it in various forms and not necessarily providing everything in or each piece of information in a single step, or everything in one single sentence or query. In fact, let's say the old way, or probably the technology that's been used or that's been in place till, I would say, 10, 15 years ago. And more recently, the system becomes a little bit more structured. And in particular, you see in this diagram, an architecture which can be used in order to describe the most recent systems, like the spoken understanding system of Alexa, for example, of maybe the system of your telephone to some extent. So, of course, there is a first step, which is automatic speech recognition. And then the string, which is delivered by the automatic speech recognition, is given to a language understanding system. And the language understanding system provides some internal structure or some characterization or some internal representation for the spoken sentence. And then there is a module which is called a dialogue tracker, which takes this new sentence. It keeps an history of the previous dialogue steps in some form. We will say a little more about this. And then this system will essentially decide, based on the interpretation of the current utterance, it will provide an input to the dialogue policy, namely once a specific interpretation is given to a certain speech act by the user, then the system needs to identify the response. And at this point, the system defines the response, and it first defines it in some sort of internal representation. And finally, there is a module for translating it into a string of text. And then again, the string of text should be turned by the text-to-speech into a spoken signal. Okay, so as you see here, this architecture is quite complex, and it's composed by multiple modules, each of them that can be with its own specific technology and its own specific strengths and weaknesses. One point that I mentioned in this, more especially whenever you want to generalize from the strict spoken dialogue system, is the task-oriented dialogue system, is the characterization of a speech act. Typically, in a dialogue, there are, even in a simple dialogue that is focused on a specific task, there may be the need to characterize the different types of statement, different types of dialogue acts. So there may be statements, why questions, yes, no questions, confirmation, disconfirmation, greetings, and so on and so forth. There is no standard accepted by the community. There are there is something, but it's not completely established, meaning accepted by everyone. And let's see example of speech acts, just to give you an idea of how our dialogue system needs to be able to understand the different speech acts. So what the greeting is maybe the most obvious, and in this case we have a greeting, but we have also the expression of a specific goal. So this is the dialogue act is labeled as hello with a task find and type restaurant, which determine the type of intent of the user. And then the system answers, you're looking for a restaurant, what type of food do you like? This is a confirmation, and at the same time it's a confirmation, but it's also adding a request to the user. And we will see other examples. This is a good one, where instead of doing simply a confirmation, the system makes a step forward, which makes the dialogue much more fluent and much more acceptable. And then there is a user request, which is labeled as inform, and the inform act of the user is replied by an inform act by the system. And then again, the user is asking, is it reasonably priced, which is at the same time seen as a confirmation and as an additional request of the price, and then the answer by the user, and so on and so forth. So you see that there may be multiple speech acts that are characterized in the dialogue. But I already mentioned that one specific category of speech act is that of correction acts. And they are really challenging. And there are various clues that may help identifying correction acts. One of them is the presence of words no, like no, correction, I don't, and that's directly from the text. But there may be other ways of trying to understand whether an act is a correction act. A speech act is a correction act. Another one is the similarity. So checking whether the current speech act is similar to the previous one may be an indication that this is the user is repeating because it's not being understood correctly by the system. There is also a possibility of considering the phonetic aspect of the user act, namely looking at or considering words that are similar but with a different pronunciation. And the example that I made earlier, also prosodic features like hyperarticulation is the one phenomenon that is described by this pronunciation of words in a, I would say, in a childish manner, by emphasizing letter by letter the words I said, Milan, right? That's the example that I made earlier about this. And finally, another feature that can help detecting the correction act is the automatic speech recognition accuracy figures. In other words, whenever you use a speech recognition system, you not only get a text, but you also get alternative strings of text, each of them labeled with a probability that a number which denotes the confidence of the system in returning that specific interpretation. So what about dialogue tracking? Well, the main approach is given by the frame filling, especially for the task-oriented spoken dialogue system. It's the frame filling that guides the dialogue, and the status of the dialogue is well characterized by the current status of the frame. Plus, the system may record other information, including eventually constraints on slots rather than values, and also keeping an history of the speech acts. So in this way, the system can create, can accumulate information that can be used in determining the response to the last speech act by the user. Here is an example dialogue. I'm looking for a cheap restaurant, and then the system asks for information, and the user provides the information about the restaurant, and then the system makes a proposal. The user then asks a question, where is the restaurant? And the system informs, and you see that in this example, the slot filling is once again quite clear. In this particular case, it's no longer the airline, but it's the choice of a restaurant, and each of the features of the restaurants are eventually filled in step by step during the dialogue, according to the frame filling paradigm. Concerning the dialogue policy, namely what kind of response, this can be phrased as a choice of what is the best action to provide in response to a given dialogue act by the user. And this can be done by taking into account the previous dialogue acts from the users, and as well as considering all the previous actions done by the system. But in fact, typically this is done by taking into account a representation of the state, which can be compactly represented by this frame variable, referring to the previous state only, and then considering the previous action and considering the previous speech act by the user. And this can be done, the training of the dialogue policy can be done by various approaches, including reinforcement learning. So another aspect that can be specifically addressed, and to some extent I already mentioned, but I want to emphasize a little more, is that the issue of confirmation. Because maybe this is one of the issues that bothers me the most whenever I have an interaction with one spoken dialogue system. So let's look at these examples which describe address the issue of confirmation. Well, one important thing that we do it all the time ourselves as human is to make sure that the information is correctly acquired by the other partner in the dialogue. So this can be done explicitly or it can be done implicitly. Let's look at some examples. Here we have an example of explicit confirmation. Which city do you want to leave from? Baltimore. Do you want to leave from Baltimore? Yes. This is the kind of systems that I particularly dislike, because it seems silly to repeat exactly what the user just said, even though for the system, understanding the location, starting location of a trip may be important. But let's look at the second way of doing the confirmation, which is, I'd like to fly from Denver, Colorado to New York City on the 21st in the morning on United Airlines. Let's see then. I have you going from Denver, Colorado to Baltimore. And here is the implicit confirmation to New York, I'm sorry. Oh, in this case, it's New York on the September 21st. Is that correct? So that's repeating a complex question. And my preferred solution to this confirmation issue is what is maybe in the example represented by implicit confirmation, because in both cases, even though, as I mentioned, the importance of this information may be worth asking for confirmation, I would much prefer a dialogue which says, I want to travel to Berlin. And the following question is, when do you want to travel to Berlin? Where the confirmation is combined with the next step in the dialogue. And similarly, I'd like to fly to Seattle Tuesday morning. Traveling to Seattle on Tuesday morning, 11th in the morning, your full name. And again, the system is not only confirming, but it's anticipating one of the steps. And in fact, I think in a couple of slides, we are going to address the issue of evaluating the performance of the task-oriented dialogue systems. And one of the key elements is to reduce the number of turn taking in order to complete the task. So from this point of view, the implicit confirmations sounds much better. Another issue is that the rejection, and the system can simply say, sorry, I don't understand that, but the system can be more proactive in the response. Let's look at this example. When do you want to leave? Well, I need to be in New York in time for the first World Series game. And the system says, sorry, I didn't get that. Please, can you say the month and the day you like to leave? And in this case, the system is acknowledging the lack of understanding of the user dialogue act, but at the same time is asking to rephrase the information in a different form, which may help the conversation so that and avoid this sense of frustration on the user, which is might be simply got by a response like, I did not understand, can you repeat, please? So these apparently are details, but in fact, they have a significant importance, and this is demonstrated by, as I mentioned earlier, by several user studies which compare different systems with different features and highlight that properly addressing these issues makes the systems much more acceptable and much better rated by the user. The generation, language generation. At some point I mentioned that the system creates its own internal representation and that it must translate this representation into a text. Just to make it clear, let's look at these examples. The system ended up with understanding that the action to be done is the recommendation of a restaurant with the name Omidi in the neighborhood Midtown and with the French cuisine. And therefore, by this, which is an internal representation, from this, the system should generate a spoken response, which could take the form, Omidi is in Midtown and serves French food, or there is a French restaurant in Midtown called Omidi. So there is a variation here that can, again, make a system more or less acceptable, depending on the ability to show naturalness in the dialogue. And there is this other example. So what I want to point out here once again is that the complexity of this overall dialogue system in all of its component is surprisingly high, and the overall performance of the system may be affected by multiple issues. So now let's go a little bit more practical and anticipate what kind of tools you may eventually use in your project. One of them is, well, actually, this is a sort of a standard at this point, rather than a specific system, called Voice XML, which is one of the XML specification, which is in particular used in order to specify task-oriented dialogues, okay, based on the specification of dialogue turns, which includes a match to be done on a specific frame or frame element, and then a corresponding output to be provided towards the user. In this particular standard, a frame is called a form, and the slots are called fields, but in fact it's exactly the same. And the one point that we're going to see in the example in the next slide is that this system allows for a grammar specification of the input, to parse the input that should fill, for example, a specific frame. Let's see the example, and this will be clearer. So the system defines various type of before this, starts with these definitions that define these two categories, no input and no match. And then we have, in this example, a definition of a form, where a form is made by a block, which is a sequence of specific speech acts or dialogue turns, I should say better, where each dialogue turns has a prompt, as in this case, which would be, which city do you want to leave from? So this is a sentence which is pronounced by the system. And then there is a section which specifies, which provides a specification for the input. In this case, the input is restricted on being one of the three sentence, or one of the three cities, San Francisco, Barcelona, New York. But here one can get or can include complete specification using a certain grammar. And in some cases, the grammar is given explicitly. In other cases, like down below, when the system is asking for a departing date, then the type date is specified here, and the system does the parsing of the date based on this specification, clearly providing support to the user, that to the designer, that doesn't have to take care of specifying the grammar for a date, the possible grammar for a date. So as you see, in this case, the construction of a dialogue system is as a simplified structure. In this particular case is a sequence, and the sequence is built according to the slot fielding paradigm. And in this particular case, there is also no selection of the domain, no selection of the intent, but given both the domain and an intent, the system provides frame implementation for frame-based implementation for running the dialogue. Another possibility for building dialogues is the so-called artificial intelligence markup language called AIML. And this, again, is one of these stimulus response patterns, and it can be used both as a general dialogue system, which I think was the initial intention of the designer, but it turns out to be much in the structure of the task-oriented dialogues, where if you use the typical frame structure that we have been discussing so far, then you can structure this stimulus response in a form that is suitable also for task-oriented dialogue. I'm not going to discuss the details of AML. The syntax is the syntax of XML documents. In each document, there are labels characterizing different elements of the specification. The pattern is the specification of the input that the system is accepting, and the pattern will enable the selection of the specific category. And then the template defines the response, And the response in this particular case is formulated in interpreting a command for the robot, like go to the kitchen with the action, go to with the destination kitchen. While the pattern hello is here associated with the response with another greeting on the side of the system. So the details of all these languages are not so important because they all share the same structure with this turn specification, where the input is given by some sort of language for matching the input provided by the user, and with it the system can associate both responses and execution of commands, and at the same time responses and command executions. A final word before we close this quick overview of a dialogue system on the evaluation. And here is an example of the kind of features that spoken dialogue system questionnaire should aim at considering, including various aspects from the text-to-speech performance to the automatic speech recognition performance, to the overall ease, to the interaction pace, to the required user expertise, to the quality of system response, to the system behavior, and finally, typically in these questionnaires, there is are you willing to, would you be willing or pleased to use the system in the future? So that's an example of a questionnaire for assessing the performance of a system. And there are quantitative measures as well, but they are very difficult to define. And in particular, for task-oriented systems, one could check the number of successful interactions, namely those interactions where the system eventually did the right thing at the end of the interaction. And then there may be measures for efficiency, in particular, the number of turns in the dialogue can be a measure of the efficiency, as we mentioned earlier. And finally, there may be also metrics that try to address the quality of the interaction itself. So it is a challenging task evaluating a spoken dialogue system. And there are no specific guidelines for the design, but certainly in this system, like in any user interface, the design process should start from understanding the user and the task, and then going through an iterative process where a prototype system, possibly supported by a Wizard of Oz approach, is tested with the users, and based on their feedback, then eventually the prototype is built and refined at multiple steps, using the feedback from the user as a main guiding principle. Finally, ethical issues are quite significant in the case of dialogue systems. I already mentioned the Thai chatbot, which learned to speak in a racist and unpleasant manner after a short interaction with other chatbots and with the users in the system. Probably in that case, the users understood that the chatbot was learning, and therefore they forced learning it to learn certain type of patterns as opposed to others. But still, it was a striking experiment that shows how important is the training for achieving a system that performs according to expectations. And just recently, I have read a paper which was about the difference in performance of spoken language understanding when comparing standard English with Afro-American English, which is created by the bias in the data sets using in the training. So in particular, for many of these tasks that require large corpora, large data sets, the danger of introducing biases in these systems is significant, and therefore in designing systems one should place a specific attention on these issues. There is another issue, which is privacy, and it is striking that some of the users of ELIZA were putting so much empathy with the system, up to the point that they wanted to be alone when talking to the system. And because they were probably disclosing things that they would not disclose otherwise, or they didn't want to disclose to a large audience. So our conversation with these systems, they may have an impact on our privacy. So that's true also for all the systems that get the response or the transcription of your spoken utterance from the cloud. They clearly are, what you say is clearly used in order to keep training the system. So you are providing your voice for free to these companies that provide this service and build this service for you. In addition, there may be dialogues in which you disclose information that you want to be disclosed, you don't want to be disclosed. And finally, last but certainly not the least, there may be a gender issue, or there is a gender issue in the gender of the speaker. The tone of the voice, the choice of the voice itself can be biased by multiple factors, gender and also race and many other things. And that's another aspect to take into considerations. Great care, treat with great care in the design. One reason why I think that dialogue systems will be more and more popular in the future for robots is because robots not always can do themselves the tasks that are requested by the users. So sometimes they need the help of the users, and therefore they have to be proactive in asking the user to help. And in this context, there is no better communication channel than the interaction using the spoken language. So spoken language is a support, a significant support to systems that we want to use, let's say, in order to support the robot in learning about our home to be cleaned, about the tasks to be accomplished, like how it should be cleaned, and so on and so forth. So it's the user helping the robot and the robot asking the user for help. And this kind of interaction, which takes the name of symbiotic autonomy, because user and robot should help each other, this is will be substantially supported by the use of natural language. So here are some examples of this kind of dialogic interactions. We are going to see them again, some of them in the context of projects. And before I close, I just want to point out that we had only one example of a paper which is based on a dialogue system, and where there is an evaluation of the interaction between the user and the robot. And it's in the context of the aim of the paper was to show that by combining the dialogue with perception, eventually the system would be able to have a better interaction with the user in order to understand from the user the specific features of the environment. So if you are more interested, you can look at the paper in the quote. At the time of this first edition of the paper, it was submitted, but then eventually it got accepted to EMAS, which is a rather prestigious venue. Okay, all the stuff on the dialogue is in the chapter 26 in the book by Martin and Jurasky and Martin, actually. And I take a couple of minutes rest before I move on with the description of the projects that will start. What time is it now? We'll start in 5 minutes. Any question before we close? Okay. If not, I will